Today we're looking at properties of exponents. We're going to use properties of exponents to simplify expressions involving powers. First, let's talk about some properties of exponents and why they are. So let's talk about a product of powers. So the first one, the definition is if I have b to the m times b to the n, that's going to equal b to the m plus n. Now let's just assume that this b right now is going to be our 2. This is our reasoning. Our m is going to be represented by a 3, and our n is going to be represented by a 2. Now 2 to the third power means 2 times 2 times 2, and 2 squared, or 2 to the second power, is 2 times 2. All together I have 1, 2, 3, 4, 5 2's. We had 3 of them plus 2 more, and that gives us 2 to the 5th. So all we need to do is add the 3 plus 2 to give us that 5 there. Now if I have a power to a power, b to the m raised to the nth power is going to be b to the m times n. So again, we have our b, we're going to represent with a 2. However, it could represent any number. Our m is going to be represented by a 2, and our n is going to be represented by a 3. So we have 2 squared, which means 2 times 2, but we're going to repeat that 3 times. So we have 2 times 2, 2 squared, times 2 squared, times 2 squared. All together, there's going to be 6 of them. So when you have a power to a power, we're going to multiply those exponents to give us a power of 6. Now, a power of a product, if I have ab to the m, that's going to equal a to the m times b to the power of m. So we're going to represent a with a 2, and the b is going to be represented by a 3, and the m is going to be represented by a 3. However, these could be any numbers. So I'm going to take 2 times 3 to the power of 3 means I'm going to have 2 times 3 3 times. That's going to be 2 to the power of 3. There's 3 3's, and there's also there's 3 2's and 3 3's. A quotient of powers, we're going to take b to the m divided by b to the n, and that's going to equal b to the m minus n. So keep in mind, b cannot be 0. It has to be a positive number. Or it could be positive or negative number, And we're going to represent b by a 2. M is going to be represented by the 5. And n is going to be represented by the 3, but those could be any numbers. So 2 to the power of 5 means we have 2 times 2 times 2 times 2 times 2. We're multiplying 2 by itself 5 times. 2 to the power of 3 means we're going to multiply 2 by itself 3 times. Now notice if we have 5 2's in the numerator multiplied and 3 2's in the denominator, 3 of those are going to be canceling, and we will have 2 to the power of 2, which would equal 4 if I simplified that. So all we need to do, since there's 5 2's on top, 3 on the bottom, 3 of them cancel. 5 minus 3 is going to give us 2. Power of a quotient. So if I have a divided by b all to the m power, what we can do is we can say that this equals a to the m divided by b to the m. So let's talk about reasoning. We're going to represent our a as a 2. Our b we're going to represent as a 3, and our m is going to be represented as a 3. However, these could be any numbers. So I'm going to take 2 divided by 3 to the power of 3. That means we're going to multiply 2/3 by itself 3 times. So I have 3 2's, 2 to the power of 3, divided by 3 3's, which is 3 to the power of 3. Now, if I have a negative exponent, b to the negative m power is going to equal 1 over b to the m power, where keep in mind b cannot equal 0 whenever we have a denominator, because you cannot divide by 0. In this example, we're going to take 5 is going to be our b, and m is going to be represented by a -2. So let's just look at this example, and we'll liken it to what we just talked about with the negative exponent. If I have 5 to the power of 3 divided by 5 to the power of 5, I have 3 5s on top divided by 5 5s on the denominator. 3 of them cancel, and I have 1 over 5 squared. So this is going to be the same as if I subtracted 3 minus 5, I get a -2. That's going to be the same as having 1 over 5 to the 5th. So we're taking and combining this thing right here. If I have if I subtract the exponent, 3 minus 5 gives me a -2. That has to be equal to 1 over 5 squared. This can also happen. Another option is if you have n to the -2 here and maybe a 1 here. Whenever you have a negative exponent, we're going to move it to the numerator, and it's going to be positive. So if it's on top, we move it to the denominator, and it becomes positive. If it's in the denominator, then we move it to the numerator, and it becomes positive. So we'll do some examples like that in a minute. Now we have a 0 exponent. Anything to the power of 0 always equals 1, but b, the base, cannot equal 0. So why is that? So let's say I have 5 to the power of 3 divided by 5 to the power of 3. What's happening is we can subtract those exponents. 3 minus 3 equals 0. Another way of saying this is 5 times 5 times 5 over 5 times 5 times 5. All of them cancel out, and our answer is going to be a 1 there. So anything to the power of 0, if we subtract those exponents, we get a 0, but that just means that everything canceled out, and so we just have a 0 here. Okay, so we're going to evaluate each expression. We're not using decimals or negative exponents in our answer. On number 1, I have 3 to the power of -2, and that's to the power of 4. So we are going to use the power of a power. If you have a power here and a power here, we just multiply those exponents together. 4 times -2 is -8. This is going to be 3 to the power of -8. Now, we never want to write our answer with a negative exponent. Do not use decimals or negative exponents in your answer. This has a negative exponent. So we're going to go to this negative exponent rule, and we are going to rewrite it. So we're going to take the -8, b to the -8, we're going to take it to the denominator, and it's going to become b to the 3 to the -8 is going to go to the denominator and become 3 to the +8. So this would be our answer here. Now I have -4 times -4 squared. This is a -4 to the first, and this is a -4 squared. We are taking two, we're going to look at the product of powers. We have the bases are the same on these -4s, and then we have some exponents. We have a -4 to the first and a -4 to the second. We're going to add those exponents. This is going to be a -4 to the third. Now I can, I sometimes when you're dealing with exponents, you can leave it like this. However, this is going to equal -4 times -4 times -4. -4 times -4 is a +16. 16 times -4 is a -64. So this would give us the answer of -64. Now, this -3 to the first times -3 to the third, that's going to be the same as saying if we add those exponents, it would be -3 to the fourth. So what that means is negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Negative 3 times negative 3 is positive 9. 9 times 9 is 81. So this would equal a positive 81. Now number 4, this is 1/3 squared to the power of negative 6. Now if you have a power to a power, you're going to look up here, we're using the power to a power. You want to multiply those exponents. So this is going to be equal to 1/3 to all to the power of negative 12. Now we do not want to have negative exponents. So I'm going to just take and I'm going to use my power of a quotient, and I'm going to take that negative 12 to both the top, the numerator, and the denominator. 1 to the negative 12 divided by 3 to the negative 12. Now remember, do not use negative exponents, and we have 2 negative exponents. What you do, you take the negative exponent in the numerator, you take it to the denominator. This is 1 to the positive 12. And 3 is going to go from the denominator to the numerator. It's going to be 3 to the positive 12. Now 1 to the positive 12 is just 1. And so my answer is going to be 3 to the positive 12. You can put that in your calculator and get an answer. But where it's a really large exponent, we're just going to leave it like this for a moment. That's going to be a pretty large number there. Okay, now 5 to the 3rd divided by 5 to the 6th. We can just take if we're dividing, we can just subtract our exponents. This is going to equal 5 to the 3 minus 6, which equals 5 to the negative 3. We do not want to have a negative exponent written, so the negative exponent is going to go to the denominator. It's going to become 5 to the positive 3, and we're just going to put a 1 on top. So this was over 1, and they kind of switch places there. Now 5 times 5 is 25, and 25 times 5 is 125, so that is going to be our answer. Now I want to look at this just a little bit different way. We could take 5 times 5 times 5 over 5, 1, 2, 3, 4, 5, 6 5s. 3 of those cancel, and I'm left with a 1 over 5 times 5 times 5 is 125. So we can look at this in 2 different ways to think about. Looking at number 6, we have our negative exponent. We never want the negative exponent. We can take it to the denominator and make it positive. We're going to have a 1 left in the numerator. If everything leaves, we'll have 5 to the 3rd times 5 to the 1st. This is we're going to add those exponents, which is going to be 5 to the 4th. This is going to be 1 over 625 there. Another way you could think about this is you could say 5 to the negative 1 minus 3 is 5 to the negative 4, which equals 1 over 5 to the 4th, which is 1 over 625. Okay, now we're getting into some variables, but it's going to be exactly the same. In a lot of cases, it's easier with variables because you don't have to figure out what those numbers equal. We have 3 p's. We have 5 more p's. All together, you just add those exponents together. We're going to have p to the 8th. We have q to the negative 4 and q to the negative 2. We add those together. That's going to give us q to the negative 6. We do not want to use negative exponents, and so we want to take that q to the denominator, where the p is going to stay in the numerator. The q goes to the denominator, and it becomes a positive 6, which will give us our answer. Okay, so number 7, if you have a power to a power, let's just remind ourselves what we do when we have it outside power of a product, we're just going to take the m and distribute it to all of the exponents. Now, if I had something like a 2 and an m here, those would multiply to become a 2m. So we're going to take whatever the exponent is and times it to be all, times it so it's m times n, but it's going to go to everything, that n is going to go to everything inside. So we're kind of combining these two here. So first thing we're going to do, we're multiplying exponents. That -2 is going to go here, here, and here. We're kind of distributing it through. So 3 to the -2. A, -3 times -2 is a +6. B, 5 times -2 is a -10. Now we do not want negative exponents, so anything with a negative exponent we're going to take to the denominator. The a to the 6 stays in the numerator. The 3 squared comes into the denominator. And the b to the -10 comes to the denominator and becomes b to the +10. 3 squared is 9, so I'm going to have a to the 6 over 9b to the 10th would be our answer for number 7. On number 8, let's just simplify the numbers first. 4 over 16. I could just kind of keep this separate. I know 4 goes into 4 one time, 4 goes into 16 4 times. So this 4/16 is going to reduce to 1/4. So I'm going to have the 1 in the numerator and the 4 in the denominator. X to the 3rd divided by x to the 3rd cancels out. So those are gone. I have a negative exponent, y to the -6. It comes to the numerator. I already have a y to the 6. I'm going to add another y to the 6. There's 6 and then 6 more. Altogether, I have y to the 12th. 1 times y to the 12th is y to the 12th, so I don't need to put that 1 there. And then in the denominator, I just have a 4. So that would be my answer for number 8. Number 9, I'm going to take anything with a negative exponent, I'm going to move it. So if I have x to the -3, I'm going to move it to the bottom. It's going to become x to the +3. Y to the -4th is going to come up top to become y to the +4th. And then we're just going to simplify what do we have. So let's look at our numerator. We have an x squared. And y to the 4th and y squared, there's 4y plus 2 more, that's going to give us y to the 6th. In the denominator, I have a 3. I also have 3 x's here and 2 more. Altogether, I'm going to have x to the 5th. So the only thing that I still looks like I could simplify, I've got 2 x's in the denominator, or in the numerator, 5 in the denominator. 2 of them are going to cancel, and then we're going to have 3 left in the denominator. So our answer is going to look like y to the 6th divided by 3x to the 3rd. Okay, consider the equation y equals 5x to the 3rd. If x doubles, what's going to happen to the value of y? So y is going to equal 5, but instead of x, we're going to put a 2x in here. But notice the x is to the 3rd power. So if I double it, that is also to the 3rd power. So I'm going to have my 5, 2 to the power of 3 times x to the power of 3. If I take that 3 and distribute it with the exponents, 2 to the 3rd is 8. So I have 5 times 8 x to the 3rd. So the difference is this 8 here. We have 5 and an x cubed, but we're multiplying it by 8. So if we double the x, it's not going to double the y. It's going to make the y 8 times the original. And that is because we are timesing it not by 2, but 2 to the 3rd. And 2 times 2 is 4 times 2 is 8.